For 1988 BC 44, we're asked which of the following series converge. And the first one is a series from 1 to infinity of -1 to the n plus 1 times 1 over 2n plus 1. Now, the first thing that I notice about this is that it is an alternating series. So if it's an alternating series, we only need to see that the terms decrease in value to 0, and they definitely do. So if we wanted to write out a few of those terms there, just to convince ourselves, we would have the first term would be positive, and it would be 1/3. Then the second term would be negative, and it would be -1/5 plus 1/7, etc. So you can see that the terms are decreasing in absolute value to 0, and it is strictly alternating. So converges by the alternating series test. Second, we have 1 over n times 3 over 2 to the n. Now, I'm not exactly sure what I would do for this one, except that I know that 1 over n is the divergent harmonic series. We could also say it's a p-series with p equal 1, so that diverges. Now 3 over 2 to the n is a geometric series with absolute value of r being absolute value of 3 over 2 greater than 1, so it diverges. Now the third problem is a little bit more tricky here, and this is going to employ the integral test. Now when you see natural logs, especially natural logs in the denominator, natural logs might be a good place to use the integral test. So the second one diverges. So we need to set up an integral here, and we would have 1 over x to the ln of x, and we want to go from 2, I will say, to b here, setting this up as an improper integral, limit as b goes to infinity. Now in this case we're going to have to do a u substitution, and if we let u equal ln of x, then du would be 1 over x dx, which is exactly what we need. And we'll still have to swap out limits of integration here. U of b is ln of b, and u of 2 is natural log of 2. Then I think we're ready to go here. We have the limit as b approaches infinity of the integral from ln of 2 to ln of b, that's not a 6, of 1 over, sorry, I forgot the dx over there. It's just 1 over u du. And again, that's limit as b approaches infinity of the absolute of natural log of absolute value of u from ln of 2 to ln of b. Alright, limit as b approaches infinity. We have natural log of b minus the natural log of 2. Now, we don't know what natural log of 1 is 0, so natural log of 2 is some small positive number. But natural log of b, as b approaches infinity, is going to be the natural log of infinity. And since the natural log grows without bound as x increases without bound, then that really is infinity minus some number there. And that does not exist. That limit does not exist. So once you see one of the parts is going to go to infinity, then there really is nothing more that we can do at that point there. So hopefully that makes sense. The natural log function grows without bound as x approaches infinity, and so the limit as b approaches infinity of ln of b is going to be natural log of infinity, which is infinitely large itself. Alright, so the third one will not converge either. So in this case we get 1 only. And that'll do it for this problem.